Good day everyone, this is Sarel van Grenen aka Mr. VG, and I am excited to be on this journey with you in advanced triangle geometry. For this specific video we are going to look at the theory behind triangle geometry. In my experience, my students have very seldomly struggled with the theory behind the triangle geometry. What they've struggled with a lot is when it actually comes to exam type questions. So I don't want to spend too much time on the theory, but I do want you to understand before we go over to the practice, which will be in the next two videos. So let's quickly start by looking at theorem 1 of 3 that will be asked. Okay, so let's look at the first theorem. The first theorem says that if BC is parallel to DE, so if BC is parallel to DE, then the ratio of AD over BD is the same as the ratio between AE over EC. And the reason we want to give the examiner is that it's line parallel to one side of the triangle. Remember, you are allowed to abbreviate parallel with those two lines. So let's quickly have a look at what it means. So AD and DB, as well as AB, their ratios must be the same on the left than it's going to be on the right. So that line DE is dividing the triangle proportionately, the sides of the triangle proportionately. So in other words, we can also relate this to the longer sides. So we don't just have to work with the small sides, we can also relate this to AB over AD, for instance, being equal to AC over AE. Please, again, you may replace AD with BD, and then you've got to also replace AE with EC. It must always be the corresponding sides that we use. Okay? I hope you're with me with this. So let's quickly have a look what it means in other words. In other words, it means the ratios between the sides are equal. An example of this could be, let's say AD is twice the length of BD, then AE must also be twice the length of EC. So if BD is 8 and AD is 16, then if EC is 6, then AE will be 12. And therefore there's that ratio that exists. So in the exam, if you have to write this, just write out your ratio and use the proper reasoning. I'm not going to look at examples at this moment of time. In our next video, we will look at exam type questions. Let's quickly have a look at theorem 1's converse. Now, theorem 1's converse says to us that if the ratio, if AD over BD is equal to AE over EC, in other words, the sides are in proportion to one another according to that line DE, then DE must be parallel to BC because the line divides the sides proportionally. This is now actually very awesome because it's the fourth way to prove that sides are parallel to each other. So if I look at proving lines parallel to each other, we actually now have 4 ways. We can use the F, the U, the N that you got taught in grade 8, but also you can now use if the sides are in proportion to one another. So with corresponding angles being equal, that's the one way to prove parallel lines. if the co-interior sides are supplementary, if the alternate angles are equal, but also now if the sides are in proportion. 4 ways of proving lines parallel to one another. So when it comes to this, let's say that AE is 3 and EC is 9. In other words, I multiplied by 3. If the same ratio exists on the left, in other words, the 4 times by 3, then we know that DE will be parallel to BC. And that is what Theorem 1's converse says to us. Let's move over to Theorem 2. Now, Theorem 2 is usually where the pawpaw starts hitting the fan. So in Theorem 2 it says, if the corresponding angles, so angle A is equal to angle E, angle C is equal to F, and angle B is equal to angle D, then 2 things happen. Okay? Before we get to the 2 things that happen, I just want to quickly say this. A big question that my students ask, but so how do I prove the angles equal to each other? That you do by using other geometry. Usually kind of a mixture between grade 11 and grade 8 and 9 geometry you are going to use to prove the angles equal. Now, what are the 2 things that's going to happen when the angles are equal? First of all, the triangles are going to be similar to one another. Now, this is interesting because in Form 2 or grade 9, we just assumed this is true. In grade 12, we actually prove it by using a beautiful long proof that is examinable and you have to know. But secondly, we also now are going to sit with proportions between the sides of the triangle. Now, I like to go according to the position in the similarity, and that's why position in similarity is crucial. AB, because it's written first and second, will be equal to AB over DE. So the ratio between AB and ED must be the same as the ratio between BC and DF, because now they're placed second and third in the first triangle and in the second one. But also it must be equal to 1 and 3, so AC, and EF because it's 1 and 3, so AC over EF. So there's 2 things that happen when those triangles are what we call equiangular. In other words, when the corresponding angles are equal. So what we are going to have a look at this moment of time is a few very important things. You must be able to rearrange these ratios. And I'm going to share with you why. Now, the why is going to come maybe after some grudging or sludging through this mud. Just why are you doing this? So I don't get it. So please stick with me, because what I'm going to share with you is few valuable tricks for the exam. So if they tell me that I've got AB over DE is equal to AC over DF, for instance, okay? Now this is not exactly the same as the one we did now earlier. What I want to share with you is that I can actually rearrange this in another way. So if I want to rearrange this, I'm going to multiply the DF to the top on the left, and I'm going to multiply the DE to the top on the right. And I'm sitting with this expression. AB times by DF equal to AC times by DE. Now I just quickly want to stop myself and just stop you before we go further. I didn't actually cross multiply. I actually multiplied by the LCD on both sides. I multiplied actually by the DE times by DF on both sides, which leaves me with this lovely expression. So what I'm going to do now is I'm actually going to take it one step further, and I'm going to divide both sides by DF. You might be frowning very much at this moment and ask, where am I going? Just be patient. But I'm also going to divide by AC on both sides. So on the left, the DFs divide away, and on the right, the ACs divide away. In other words, I now rearrange this to be AB over AC and DE over DF. The reason why I want to do this is because then on the left I've got one triangle ABC, and on the right I've got triangle DEF that I want to work with. And this is a valuable trick for the exam. So let me quickly share with you the trick, the dirty little tricks that I like to do, because one of the biggest issues I've seen in exams is students don't know where to start. So if I want to know where to start, let me share some exam tricks with you. If they ask me, so if I want to prove that triangle PQR is similar to triangle QRT, let me just explain what R dot T dot P means. It means ready to be proven. It means that's what I want to prove. So the question would state, prove that triangle PQR is similar to triangle QRT, for instance. What I actually need to prove is the following: that angle P is equal to angle Q, because they're written first in the two triangles. Angle Q must be equal to angle R. And thirdly, angle R must be equal to angle T. The beauty behind this is we actually give you which angles you need to prove equal to each other. Now that is exciting, because then you can start looking, how am I going to make that happen? Remember, how do we prove the angles equal? Well, that's using last year's work. Another little dirty exam trick that I want to share with you, and I will explain this more in the second exam type questions when I do this, is if they ask me to prove some expression like PQ times by RT equal to AQ times by TS. Let's say they ask me to prove this. What I like to do before I jump into anything, I'm actually going to rearrange this. So what I'm going to do is I am actually going to divide the RT, say, to the right, and divide the AQ to the left. And I'm going to be sit with PQ over AQ equal to TS over RT. I encourage you to see exactly why and how I can do this simply by looking what I did here on the right of the board. Again, the reason why I'm manipulating my expression is because now on the left I have a triangle PQA, and also on the right I have triangle TSR. So that would mean in my sketch, if I could work in triangle PQA and triangle TSR, and I can prove them similar to each other, then I'd be able to get an expression that leads to that, which in return is going to lead me to what I actually want to prove. So these two tricks are simply tricks to teach you, to show you exactly where do I start when I'm asked specific questions. Now I know it sounds very simple, and I know it might sound overly simple, and it's not always going to be a foolproof method, but it's going to be a method that will give you a starting position. Now, theorem 3, ladies and gents, is simply the theorem of Pythagoras. Now, this theorem you have actually done since grade 8. You've done it so many times. You've applied it so many times. So what is different in grade 12? The only thing that's different is that in grade 12 we prove the theorem of Pythagoras and its converse. We're not going to really apply it much, and we are not going to ask it often in an exam. But I'm confident that you would be able to pull this off. Remember, you can always ask if there's anything that I said that doesn't make sense, or even let me know if I make a mistake. It happens so quickly and I don't even realize it. So this is Mr. VG signing out. Please remember to subscribe to the channel. Please remember to look for the next video, and have an awesome, amazing rest of your day. Keep well. Cheers.